In this video, we are going to discuss the role of the transport layer in computer networks and its two protocols, TCP and UDP. The transport layer's task is to create process-to-process communication. In addition, it performs error control, flow control, and congestion control to guarantee the reliability of communication. So the transport layer's ultimate goal is to provide efficient, reliable, and cost-effective data transmission services to processes communicating on the network. It relies on the host-to-host services of the network layer to provide transportation service to the application layer. The network layer receives the segments of the transport, cuts them up into small packets, and then routes packets individually. The network layer is a best effort layer that tries its best to get the packets to their destination. However, due to congestion and error, packets may be lost or delayed. The transport layer compensates for this shortcoming through retransmission, acknowledgement, sequence number, and timer. There are various terms to refer to network devices, information units, and addresses in the TCP/IP layers. This table summarizes TCP/IP layers and their associated terms. As shown here, the transport layer's function is to connect processes. Process refers to an active application that is consuming computers' resources such as CPU time, memory space, as well as network bandwidth. For example, a web browser displaying the contents of a website is a process that communicates with the related web server. The information unit in the transport layer is called segment, and the address used to identify processes is called the port number, which is a 16-bit address. The transport layer offers two types of services: reliable or connection-oriented, and unreliable or connectionless. Its important protocols are TCP, which provides reliable service, and UDP, which offers unreliable service. For reliable services, the transport protocols such as TCP has to go through three steps. First, connection establishment. Second, data communication. And third, connection release. In reliable services, reliability outweighs data transmission speed. Applications such as web browsing, email, and file transfer that are error sensitive use reliable protocols. In these applications, errors cannot be tolerated. Let's say an email to set up a meeting is sent from a user. If an unreliable protocol such as UDP is used, the message may be changed during the transmission, and it could end up with inaccurate information delivery. Thus, TCP, which is a reliable protocol, is usually used for web browsing, email, and file transfer. However, there are some applications in which transmission speed outweighs reliability. For example, in video streaming or domain name system, error is tolerable to some certain extent. What matters most in such applications is the fast delivery of data. Let's take YouTube as an example to see what would happen if it used TCP. Each segment of the video has to go through connection establishment, data communication, and connection release. It takes much longer to receive a video with TCP. So for applications that can tolerate error to some certain levels, UDP fits best because no connection is established or released between sender and receiver. The network and transport layer share some characteristics. For example, both provide addresses. They offer reliable and unreliable services. But there are differences between the service of the transport layer with the network layer. The network layer that lies below the transport layer is responsible for host-to-host packet delivery using datagram and virtual circuit. The transport layer builds on top of the network layer to provide data transport services between processes. Also, it guarantees the reliability of transmission using error and flow control mechanisms. However, the network layer provides best effort service, meaning that the IP protocol of the network layer tries its best to deliver packets to their destination, but some packets may get lost halfway through transmission. The transport entities are mostly implemented in the operating system of the user machines, and therefore users have control over the functions. However, the network layer mostly runs on the router that are operated by the ISPs. This picture shows the header of the UDP segment. It has 4 fields: source and destination port numbers, which are 16 bits long. Port is the address used in the transport layer to identify the source and destination processes. The UDP header also includes UDP length and UDP checksum. UDP performs minimum error control, and therefore it is mostly used in applications such as video streaming, in which transmission speed is more important than transmission reliability. The other application that uses UDP is the domain name system, or DNS, that is used to look up the IP address of a domain name. This small header helps processes have fast communication for large files such as video. This picture shows the header of a TCP segment. It includes source and destination port numbers, as well as sequence numbers, acknowledgement numbers, and flags such as SYN, FIN, and ACK. Sequence numbers are used to trace segments between source and destination devices. Acknowledgement number notifies the source that the last transmitted segment has been delivered to the destination, and it can pick up transmission where it left off. Flags such as SYN and FIN are used to establish and release the connection between clients and servers, and checksum is to find errors. Compared to UDP's header, it is much larger, so it will take more bandwidth to travel over the network. But to be able to guarantee the reliability of communication, these extra fields are necessary. This table lists the well-known ports associated with their applications on the internet. Port 20 and 21 are used for data transfer. Port 25 is the protocol of the SMTP, which is used in mail transfer, and port 80 is used for web communications.